Hello, I welcome you all for this session on instruction sets, a case study. With some examples, let us look into the instruction set. In the previous section, we have discussed about the instruction sets in detail, the different instruction sets available. So, I'll have a quick recap about the instruction set. PIC16F877 has 35 instructions altogether. Each and every instructions are 14-bit in width, and every instructions means this PIC16F877 follows RISC architecture. That is, every instruction is combined together. Many operations are combined together to give a single instruction. So here altogether 35 instructions are there, and these 35 instructions are categorized into 6 different instruction sets. So these move instructions are categorized into move, then clear, swap, complement, rotate, and all these instructions are categorized under register instructions. Then add, subtract, and all these are categorized into arithmetic instructions. Then and, or, all these XOR or all these are categorized under logical instructions. Then bit, set, increment, go to, call, return, all these are categorized under test, skip and jump. All these are conditional instructions. Then control instructions are also there. No operation instruction, sleep instruction, and clear watchdog timer instruction. So watchdog timer is a hardware timer which gets reset after a particular time if the system hangs or if any problem occurs. So that can be set to. So these are the different instruction sets available. Now as a case study, let us take few instructions and let us see before execution of the instruction how the registers looks, and after execution of the instruction how it will be. For example, let us assume this instruction add WF FSR, 0. So this W denotes the working register and F denotes the file register. So this here FSR, the name of the file register being used, and 0, this is the D, this is the syntax or the format for these instructions. And the 0, it denotes that when 0 is mentioned, the result will be stored in, that is, if D is equal to 0, the result will be stored in the working register. If D is equal to 1, the result will be stored in the file register itself. If D is not mentioned, obviously, as a default case, the result will be stored in the file register. So now let us see. So W register here, a value of 17 is being assigned, and file register has the value C2. Now after addition, 17 plus C2, D9. It is obvious. So D9. So how and why this D9 will be stored is, it has to be, as the instruction says, it has to be stored in the working register because this D is equal to 0. This is the syntax. This is D. D could either be 0 or could be 1. If it is 0, the result will be stored in the working register. If it is 1, the result will be stored in the file register. In this case, D is equal to 0, and so the result has to be stored in the working register. Now see, after execution of the instruction, the value in W register has been replaced by the new value. That is result of addition of these two values. So this is one case. And another case is add WF, INDF. So here you see this INDF, it denotes again addition with a working register and a file register. And here this file register is mentioned as indirect addressing mode. So if it is a direct addressing mode, the value from the file register will be picked as such. Suppose if it is indirect addressing mode, then the file register will hold an address, not the data, not the direct data. It will hold the address, and that address will hold the data. This is indirect addressing mode. So see, now the file register contains an address, and this address will hold the data. And now after completion, here nothing is mentioned, either 1 or 0, nothing is mentioned, and obviously so the file register will be updated. Here you see this is the file data from the file register. This is indirect addressing mode. This C2 denotes an address, and that address holds this data. Now after execution, here since D is not mentioned, as a default case, one will be considered, that is the result will be stored in the file register. So see, the data in the file register has been stored. This is one case. Now let us look into another case, that is an AND operation, the logical operation. So AND WF, obviously it denotes that AND operation takes place between two datas. One is in the W register or the working register, and the second one will be in the file register, FSR. Now see here, one data is available. This is the instruction. One data is available in the working register. Another data is available in the file register. And operation is being, an example was being given here. In this case, after completion, since the D value was not been given, on a default case, file register will be taken as the place to store the result, and so this file register gets updated. And the same instruction here, if 0 is being given, here nothing, D for D, nothing was given. Suppose if we mention 0, then see here the file register, the working register gets updated instead of the file register. So this is another case. And let us look into another case, that is clear F register. So if clear F register has been given, clear flag register. So flag register, the value is 5A. So it means that after once if it is given as clear, then whatever the value is there in the register will be made to 0. That is, will be reset totally. So now after execution of this instruction, this flag register is being changed to 0. Now see, in the previous section we have seen which instructions affects which flags. So this instruction affects the 0 flag. So immediately when this flag register is being set, automatically the flag registers will be checked, and then here it is 0, so 0 flag has to be set. Next case is clear W register. Here also the W register is 5A, and once after execution of this instruction, the W register is totally reset. And once if it is reset, this is again in an instruction which edits or which updates the flag register. So since the working register has been made 0, the 0 flag has been set. So few instructions are there that affects the flag registers. And this is another example, complement F. So here again complement file register, and the register name is mentioned here. And here we have given D. D is equal to 0. If D is equal to 0, obviously it means that the result after complement will be stored in the working register. So see here, this register remains the same after instruction execution, but the working register value is being updated to the complemented value. So that is how, that is the meaning of if we give a 0 here. And next is decrement. Again, in the case of decrement, file register will be decrementing. Once after decrementing, if it is 0, then the 0 flag will be set. So these are few cases how an instruction affects the flags, how the instruction affects the file registers, how on what basis the instruction affects the working register. These are different cases we have seen, and now you can make a self-assessment for yourself. Thank you.